Today, we are going to tackle one of the absolute monsters from the grade 12 chem paper. You know the one.
Yep, I'm talking about that one titration question. Look at this, a massive 17 marks. So we're going to make sure you're ready to scoop up every single one.
Okay, let's get into it. This can be more than 10% of your entire paper. Grab your calculator, maybe a piece of paper, and solve this right along with me. And hey, if this helps things click for you, make sure you're following on TikTok and subscribed on YouTube because I'm dropping more of these breakdowns all the time. Okay, so when you see a big question like this, where do you start? Well, we're going to start with the basics. We're going to grab those easy marks first, the definitions, the simple concepts, just to build up some confidence right out of the gate. So, question 7.1 kicks us off with this. Define the term weak base. Now, for 2 marks, you know they're looking for something really specific.
And here's the deal. Precision is everything. A weak base, it's a base that ionizes incompletely in water. That's your first keyword. And what's the result of that? It forms a low concentration of hydroxide ions. That's your second keyword. You have to have both of those, incompletely and low concentration, to bag both marks. Seriously, write that down.
All right, next up, question 7.2. What is the formula of the conjugate acid of the carbonate ion, CO3 2-? This is one of those quick, easy 1 markers. Remember the rule. To find the conjugate acid, what do? You just add a proton, right? An H+. And boom, the answer is HCO3-. Just like that, an easy mark. See, we're already 3 marks in, and we haven't even touched the calculator yet. Awesome. Let's move on to the data. Okay, section 2, decoding the titration data. Now, listen up, this is a super important tip. When you see a table of data like this, don't just rush into the calculations. Take a second, read it carefully. Simple mistakes here can cost you big time later on.
So here's the table from the experiment. We've got 2 runs, and you'll notice there are 2 missing values, P and Q. Our first job is to figure out what those are. And really, this is just a test to see if you understand how a burette works. Okay, let's think about it. For P, that's the final reading. So you take the initial reading and you add the volume of liquid that you used, right? Simple addition. For Q, it's the initial reading. So you got to work backwards. You take the final reading and you subtract the volume that was used. So for run 1, P is going to be 6.5 plus 20.05, which gives us 26.55 centimeters cubed. There's P. And for run 2, Q is going to be 48.3 minus 20.15, which comes out to 28.15 centimeters cubed. Perfect. That's 2 more marks right there. See how we're just chipping away at this question? We're building some serious momentum now. Okay, question 7.4. This is a classic one. They ask why methyl orange is the right indicator for this specific titration. This is all about connecting the theory to what you'd actually see in the lab. So here's the logic, and you need to lay it out clearly. What are we reacting? We've got a strong acid, HCl, and a weak base, K2CO3. Now, whenever you mix a strong acid and a weak base, what kind of solution do you get at the endpoint? It's going to be acidic. The pH will be less than 7. So you need an indicator that changes color in that acidic range. And that's exactly what methyl orange does. Its range is perfect for this reaction. That's the whole reason it's the best choice. All right, team, deep breath. This is it. The core calculation. Question 7.5 is where the big marks are, 5 of them, for figuring out the concentration of the potassium carbonate solution. Now, I know a 5-mark calculation can look scary, but don't panic. There is a method, a 4-step plan that works every single time. First, you calculate the average volume you used. Second, you grab your titration formula. Third, you get your mole ratio from the balanced equation, super important. And fourth, you just substitute everything in and solve. Follow these steps, show your work, and you'll be golden. So you take your average volume, you plug in all the numbers, and when the dust settles, you get your answer. The concentration, CB, is 0.0622 moles per cubic decimeter. 5 marks, done. Okay, we are so close to the summit now. This is the final push. Another 5 marks for question 7.6, where we have to find the value of X in this hydrated salt formula. And here's a really crucial point, not just for the high flyers, but for everyone. You absolutely need your answer from 7.5 to even start this question. See how it's all connected? One small slip up earlier can have a knock-on effect. So let's see how we use that previous answer.
Again, this might look complicated, but it's just a chain of formulas you already know. Step 1. Use the concentration we just found to calculate the moles of K2CO3. Step 2. They gave us the mass of the hydrated salt, so we can use that to find the molar mass of the whole thing. Step 3. Now we set up an equation. The molar mass we just calculated is equal to the molar mass of K2CO3 plus 18 times X. And from there, it's just algebra to solve for X.
And you know you're on the right track when you do all that math and you get a nice, clean, whole number. The value of X is 2. So the full formula is K2CO3.2H2O. And with that, we have conquered the question. Amazing. Okay, so let's zoom out for a second. What's the big takeaway here? What's the exam-winning strategy for any titration question you might face? Think of this as Mr. Cheese titration checklist. First, always start with the definitions. They're easy marks. Second, double-check that data table. Do you need to calculate an average? Third, the balanced equation is your best friend. It gives you that vital mole ratio. Fourth, show all your steps. And finally, remember that these questions are often linked. The answer to one part is often needed for the next. Follow that, and you're putting yourself in a fantastic position.
And that is how you conquer all 17 marks. You've totally got this. If this explainer helped you, imagine what else we can tackle together. Subscribe on YouTube for even more content.
So, what's next? What's that one question you're always dreading? Drop it in the comments below, and maybe we'll break it down next. Let's keep learning. See you in the next one.